Hydrohalogenation Organic Chemistry video. So we have an alkene with HBr. So that's the problem that we're going to be doing. So this can be mistaken for another type of problem where you have something like this and a peroxide underneath. Um, and these two questions are completely different. The one that we're going to be working on is Markovnikov, which is going to be on the most substituted carbon. And the one with the peroxide or a solvent is going to be with the one with anti-Markovnikov, which means least substituted. And I'll be explaining that throughout this video. And there's going to be another video on the peroxide one. Right. So Markovnikov means going to the most substituted carbon. So for example, most substituted can be tertiary, secondary, or primary. And so these are different types of um, like stabilities and substitutions. And so you know they're tertiary or secondary by looking at the adjacent carbons. So if we're looking at this middle one, it goes to 1 carbon, 2 carbon, 3 carbon. So it's just extending anything that extends to another one. 1 carbon, 2 carbon. That center one goes to 2 carbons. So if we start right here, we go down the line over here, that's only 1 carbon that extends to. It doesn't go like 1 and then 2. It only goes to the one that's adjacent to it. So this one's primary. If we're talking about this carbon. If we're talking about this one, it extends to 2. Right, so now that we got some of the basics down, we can look over here on this problem, and the way that we do these problems are that it goes to the most substituted carbon. So which do we have here? A and B. So we have A, which is going to be secondary. We have B, it's going to be primary. So how do we get the answer? A goes to adjacent 1, 2. So it's secondary. So far that looks to be the winner. And then B goes to the adjacent, which is just 1 carbon, which means it's going to be primary. And so according to our list, secondary is going to be more favorable than primary. So now that we got that down, it's time to do the reaction. So this is what happens. The double bond right here attaches to the hydrogen. So then the hydrogen donates its electrons back to the bromine. And so when that happens, it forms a hydrogen attachment to our original molecule. And so then what happens after is that we have a leftover bromine because the hydrogen attaches to this and it donates back to the electrons. So that's what like leaves the bromine charged like that. And also because that formation forms, there's gonna be a carbocation. Why does that happen? Well, because first, the center carbon already has a hydrogen, right? And when you take away that bond, it's only gonna have three connection points. And so how do we get that positive charge? Carbon um, has a charge of +4, and when each bond is like minus, so -3, that gives you that +1 charge. And so what happens is that bromine attacks the carbocation, and when it attacks it, what it's doing, it's forming a bond with it. Whenever there is attack, it's forming a bond. And so this is what happens. The bromine is formed. And on an exam, you wouldn't have to draw this hydrogen. It's going to be just implicit that there is a hydrogen there. And so this is your final answer.